Sometimes in the course of my teaching new sixth graders, I have the students repeat a rule. You may recall that fractions mean division and the numerator goes inside always. There's another one. There are a few that are relevant to 5th and 6th grade. How about to add or subtract decimal numbers, line the decimal points up, add or subtract as you would with whole numbers, and then bring the decimal point straight down into the answer. That's a little bit more wordy than the other one, but it works. We're going to see that when we get to multiplication with decimal numbers, that rule does not apply. Multiplication is a different animal. We approach it differently. And division will have its own set of rules as well. But you're familiar with them by now. You should be. This is a review opportunity to really master the operations with decimals. Get to the point where you have no problem whatsoever with them. Let's focus in this video. I think at this point I'm going to be dividing the first installment into 3 parts, and we'll deal with addition and subtraction. And I just stated the rule. To add or subtract with decimal numbers, line the decimal points up, add or subtract as usual, and bring the decimal point straight down into the answer. One thing that's not ideal about that rule is, why do you line the decimal points up? And not only that, but lining the decimal points up is really just a means for getting the place values correct. For example, you can't just add tenths with hundredths unless you make some kind of conversion. So, in other words, let me try to think if I can come up with something that you can't do. Well, what if you have to add 3.6 and 5.95? Well, I think you all know this by now. If we're adding or subtracting, we cannot have this. Those decimal points are not what I call lined up. Lined up means one on top of the other. And the problem is that it's really a problem of different denominators as far as fractions are concerned, right? Because this 5 is 5/100ths. It had this part of the 5.95 has 100 in the denominator, and this 6 here, 3 6/10. The 6 is, as a fraction, is 6/10. It has a 10 in the denominator. So you can't just add 2 fractions with different denominators without making some kind of adjustment, as you know, right? Get a common denominator. Well, this idea of lining the decimal points up is really like that. It's like having common denominators. 3.6 plus 5.95. If you just follow the rule straightforward, 3.6 plus 5.95 like this. Now this will get you the correct answer. Now you might notice the decimal points are lined up one on top of the other, which you must do with addition and subtraction. Now you might ask yourself at this point, well, what digit is here? Remember in the first video we talked about we can always tack on a 0. So that's really part of what's going on here. Of course, people know they could tack on a 0 there, 5, 15, carry the 1, 9, and then at this point you bring the decimal point straight down, and there's the actual answer to the decimal addition. But let's look a little bit more at the y of it. And please understand, you're not going to do this yourself. How are you going to come up with the answer to this decimal addition? The way I just did. But this is the why of it. And if you understand the why in math, you're much more likely to remember the how. All right? And it's a more enjoyable experience. if you're doing things in math because they make sense to you, make sense with everything else you've learned about math in the past, that's a much more enjoyable experience than if you just do what I tell you to do. Of course, teachers always want the students to do what they ask them to do, but it'll be more rewarding if you buy into it. Well, this is 36 tenths. And again, you're not going to be writing it out like this all the time, or probably none of the time. But that's 36 tenths. Notice a 3 and a 6 is the numerator. To the right of the decimal point is one digit, so there's 1 0 in the denominator. Okay? We went over this in the first video. Plus, now what is that as a fraction? Well, the digits are 595, so 595 is the numerator. The denominator is a 1 followed by, this time, 2 zeros. There are 2 zeros to the right of the decimal point. So here we see what I mentioned before about we don't have a common denominator. We need a common denominator. Now, we don't have to go all the way up to 1,000. Sometimes when we're adding fractions, our common denominator is the product of the two. But it should be clear that we can use 100 as our common denominator. If we multiply the top and bottom of that fraction by 10, we will have 360, 36 times 10, over 100 plus 595 over 100. And let me say something about fraction and decimal calculations, a general statement. When we learn about fraction and decimal calculations, we are reducing our work to whole numbers. So don't get me wrong, we're not adding two whole numbers here, obviously. But the work that we do to get the answer is adding two whole numbers. To get this answer, and I said that in the rule that I said, add or subtract as usual and bring the decimal point down after you line it up. So it's part of that rule as well. Math builds on what comes before. Hopefully, through grades 1K through 4, we've learned how to add, subtract, multiply, divide with whole numbers. We add fractions and decimals into the mix, but in the course of doing those calculations, we revert back to the whole number operations that we already learned. So you know that when adding two fractions, the denominator stays the same. So this is going to be some number of hundredths. Well, how many hundredths? 360 plus 595. Okay? Now, I erased it, but I already essentially added 360 plus 595 when I did it in the decimal form. When I wrote this, and then, I asked, well, what digit is here? 0. Okay? The decimal points were lined up. And notice I can tack that 0 on because of equivalent fractions. 360 over 100 is the same as 36 over 10. And 360 over 100, there are 2 zeros here, so the decimal point is here, 3.60, right here, okay? And I already added the whole numbers and then brought the decimal point straight down. There was a 5 over here, right? 15 carry the 1, a 5, and a 9. Is that right? Yes. So that's the answer. As a fraction, 955 hundredths. There's sort of an agreement in math. If we're given a problem, given the numbers in decimal form, we give the answer in decimal form. I mean, if somebody wrote that on their paper as the answer to this addition, I'd have to mark it correct. I might say, well, because we're sort of expected to give the answer as a decimal, we now, apply the rule. There are 2 zeros here. So we write the 955 in such a way that there are 2 digits to the right of the decimal point corresponding with the 2 zeros there. And that's, sort of taken care of in that idea of bring the decimal point straight down. When you go through it the way, the standard way, like I did before, and you bring that decimal point straight down after they're lined up, you get the same result. So again, you're going to do this addition the way I did here, not writing out all of that, but this, all of this is designed to get you to see that we're really adding two fractions, and the more you understand the structure and why we do things, the better you'll be at doing the calculations, remembering the how. In 6th grade, when I'm testing whether my students can add decimal numbers, I like to do something like this. Adding 4 numbers, and they have various numbers of places to the right of the decimal point. And I do that on purpose, make sure students can handle that. 1 digit to the right of the decimal point here, 2 digits to the right of the decimal point. This is the whole number 8. It has no digits to the right of the decimal point. This one has 3 digits to the right of the decimal point. You can probably all do this at this point. You know, one of the issues is, where's the decimal point on the 8? Well, it's at the end. It's in the right here. And sometimes I have my students say that when, you know, adding on to the rule that I mentioned earlier. If we have a whole number, like 8, the decimal point is at the right, the end of the number. And sometimes they say, like a period is at the end of a sentence. Here's 8, period. Might help you remember. But I want to take a little different approach, and again, not how you're going to do it. What's the highest number of digits to the right of the decimal point? It's 3, okay? And the denominator, therefore, over here, with this number as a fraction, the denominator is 1,000. It's a 1 followed by 3 zeros. So this may sound strange, but what's the common denominator of those 4 numbers? You might say, well, Ms. LaBelle, these aren't fractions. Yes, they are. These are fractions. And the common denominator is going to be 1,000. Eventually. How do we write that number as a fraction? It's a 6 in the numerator. The denominator is a 1 followed by 1 0. So it's 6/10. This one, 9 and an 8 for the numerator. The denominator is a 1 followed by 2 zeros. 1 2 1 2. And again, don't count the 1s, it's the zeros. The number of zeros matches up with the digits to the right of the decimal point. Okay, 8 is 8 over 1, right? You could also look at it this way. How many digits are there to the right of the decimal point on the 8? 0. There are none. So you put a 1 in the denominator, followed by 0 zeros. May seem strange to look at it that way. This is a decimal number. Whole number, we use the word decimal in different ways. In a general sense, our entire number system, the way we learn as first graders, place value, the 1s, the 10s, the hundreds, that's decimal. Later on, we sort of, usually when we talk about decimal numbers, we're talking about when there are digits to the right of the decimal point. But technically, whole numbers are decimal as well, because the DEC in decimal means 10 from Latin. Just think of decade, DEC, decade. And by the way, you might say, well, what about December? December is the 12th month. Well, it used to be the 10th month. December used to be the Roman name for the 10th month, and then through various historical reasons, it got, now the 12th month. That's true of November. The NOV in November means 9. But see, that's always two off. It's a decimal number, the 8. And we'll finish up here with 5736, the digits we see. The denominator is a 1 followed by 3 zeros, 1 2 3 1 2 3. So we now have 4 fractions to add together. We need a common denominator. We've written the 8 over 1 as a fraction. All right. The common denominator is 1,000, so we're not going to change this. We're just going to keep 5736 over 1,000. This one here, of course, we're going to multiply the top and bottom by 100 and get 600 over 1,000. Equivalent fractions, multiplying the top and bottom by the same number, getting an equivalent number. It looks different, but it's the same number. Times 10 here, again, to get the common denominator of 1,000, plus 980 over 1,000. And what do we multiply the top and bottom of that one by? What do you multiply 1 by to get 1,000? 1,000 times 1,000. So we end up writing the 8 as 8,000 over 1,000. And if I ever gave you that 8,000 over 1,000, it's an improper fraction. What's it equivalent to? It's equivalent to 8. See it as a division. 8,000 divided by 1,000 is 8. So now, how do we add those four fractions? Well, we never never add the denominators, right? The denominator is going to be 1,000, and the numerator is going to be the sum of 600 plus 980 plus 8,000 plus 5,736. We add those four whole numbers to get the numerator of our fraction answer. This is what I meant earlier about decimal calculations revert to, in the course of doing them, we come back to the whole number operations that we know. Now, because these are whole numbers, you know, a young person knows with whole numbers. Let me do this now. Do I have enough room? I guess not. What to do here? What to do? Well, you won't be able to see the whole thing at once, but okay. I guess I can squeeze it in here. All right. What I'm doing now is adding the numerators. I've got 600, and a young person knows, you know, with whole numbers, we sort of, what we call in typing right justify. Everything gets pushed over to the right, right? The 8,000, like that. The 5,736, like that. Okay? These are whole numbers. These numerators. So we do the whole number addition. 6, 15, carry the 1. 16 and 3 is 19, carry the 1. 9 and 5 is 14. So the numerator here is 14,956. And that's the answer. Except for that agreement that if we are given a decimal problem, we give the answer as a decimal. Well, 1, 2, 3 zeros. You see how that introductory video, you might have thought, well, yeah, he told us that before. But this idea of, you know, we can look at this, the denominator has a power of 10, so 1 followed by zeros. We just like rewrite the numerator, take the digits of the numerator, a 1, a 4, a 9, a 5, and a 6. And then we have 3 zeros here, so we have to have 3 digits to the right of the decimal point. So in decimal form, our answer is 14.956, or 14 and 956 thousandths. We really just took this improper fraction and rewrote it as 14 and 956 thousandths, except in decimal form. Now, you're not going to do all of that. What are you going to do instead? I think you can see most of this now, yeah. Well, let's come back over here. And this was the addition of the whole number numerators of our fractions. But how about this? How about if I put, I'll do it in red, a decimal point here, whoops, something's not right here. What's going on? Nope, they don't go there. Sorry. The decimal points go here, 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 and here. Right? Line the decimal points up. Okay? 0.6. Let's pretend I just started with the 0.6 without putting the zeros. Then 0.98. Notice I put the decimal point of the 0.98 right below the decimal point for the 0.6. And then the 8, I have to realize it's 8 point. So putting that decimal point at the end or to the right of the 8 So there it is, lined up with the others, okay? And then the 5.736. Oh, oh, I'm sorry. I'm 20 minutes into a video and there's a mistake, a transposition error. I wrote the number wrong. It's 5,000, it's 5.736. I wrote 5.376. All right. We'll make a little change here and then I'll change the other one over there. 7, 3. I think everything I did was right except copy the wrong number. And then I'll have to re-add these now. Ordinarily, I wouldn't have to re-add, but I copied the number wrong. So 6, 1, 11, 1, carry the 1, 16, and 7 is 23, carry the 2, 15. So this number over here should have been 15,316, which of course changes the decimal answer as well to 15.316. Sorry about that. But getting back to this here, now we just bring the decimal point straight down. And there's the same answer. Okay, so when we line the decimal points up in adding and subtracting, and then we tack on zeros where necessary, what we're really doing is we're adding a bunch of fractions and giving them a common denominator, which is a power of 10. So I think we have to do a little subtraction. Sort of for practical reasons in math, we don't generally subtract more than two numbers, one number minus another number. You can have a string of subtractions, you can do 8 minus 3 minus 2, but we generally aren't given problems with decimals anyway like that. We can have a string of decimals or fractions that are added together. That's typically done. Generally with subtraction, it's just one number minus another number. And the subtraction has sort of its own issue. I'd like to point out to you 9.8 minus 3.67. Now, I lump addition and subtraction together as far as stating the rule is concerned. To add or subtract decimal numbers, line the decimal points up, tack on zeros where necessary, add or subtract as if they're whole numbers, and bring the decimal point straight down into the answer. So if we follow that reasoning of that rule of lining the decimal points up, wouldn't we get that? But here's a place where students often go wrong. This is a very common mistake in middle school math. Students might like to just put a 7 down there. Now, that's wrong. If this were an addition sign, it would be okay to put a 7 there because there's a 0 you could tack on here. 0 plus 7 is 7. But for subtracting, we have to tack on that 0. I'll put it in red, tack on that 0. And then we add or subtract as if we have whole numbers. And if you're subtracting 980 minus 367, you're not going to have a 7 there. Of course, you're going to have a 3 because you have to do some renaming. And again, we're thinking of these as two whole numbers. So we will make this a 7 and this a 10, right? And then a 1 here, a 6 here, and we bring the decimal point straight down into the answer. Of course, you can check this. You can always check a subtraction by adding these two, adding up. 6.13 plus 3.67 will give you the 9.80 or 9.8. So be careful of that aspect of subtraction. Just real quickly though, I'd like to, like we did before, this is 98 tenths, right? There's one digit to the right of the decimal point, so 1 0 in the denominator. The numerator is the 9 and the 8, minus, we've got 367, that's the numerator. The denominator is 100 because we've got 2 digits to the right of the decimal point, and so we need 2 zeros following the 1. We don't have a common denominator. The common denominator, of course, can be 100. We multiply the top and bottom by 10 here and get 980 over 100 minus 367 over 100. Now, of course, we never add or subtract the denominators. The denominator is 100. The numerator is a whole number subtraction. We do 980 minus 367, which is essentially what I already did, right? When we wrote this, and I made a point here that you've got to put that 0 there, and then you're going to pretend you're doing 980 minus 367. This 980 over 100 is that decimal number, isn't it? 9.80. So by tacking that 0 on like that, you're really coming up with an equivalent fraction for the 9.8, changing the 98 tenths into 980 hundredths. Okay? Over here, when I did the subtraction and got a 3, a 1, and a 6. Yeah, a 3, a 1, and I hope that's the answer. I hope earlier I got 613 over 100. So if we continued with the fractions, we could then rewrite that 613 hundredths in decimal form like that. 1, 2, 1, 2 zeros. I think that's enough for addition and subtraction. And in a third video for this first of 3 summer installments, we'll deal with multiplication and division. Bye-bye for now.